A highly distributed system with endless edge points can outsource data collection to a universe of locations and even include them in a workflow, expanding its operations. Challenges come when you have endpoints which contribute to your organization and systems, but you don't exactly trust. They can be newcomers you don't know enough about, or entities with a history of misusing the data your systems give them access to. You want the information they amass and the value they create to be replicated throughout your system, but you don't want to take too many risks to get it. Filtered replication rescues you from the rock and the hard place. It's the art of enabling non-trusted edge points to access your system in a limited manner, replicating the information they produce in a non-trusted format. RavenDB, a distributed document database for over a decade, enables a system to accept non-trusted data, but to pass it into your database in a secure manner. Today, RavenDB CEO Oren Amy shows you how to expand your distributed system to include non-trusted edge point entities while maintaining permissions, security, and data integrity. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi everyone, welcome to this webinar. I wanted to talk about filter replication, but this is one of those features that is very much meant to handle one scenario. And before I can explain what it's trying to solve, I need to explain what is the actual scenario. So let's talk about data distribution. Right now, if you have a single server, then if that server goes down because of a hard disk error or because a blackout or I don't know, some error with capacity at the cloud infrastructure, whatever those are, then you're out, you're down. If you are running in an environment where being out costs you, and most of us are, then that's something that you want to avoid. So you typically run on multiple servers. Now, this is the centralized model for data distribution. We have one entity and one sort of database. Why do I say sort of? Because you have a cluster. This cluster is allowing you to distribute your data, handle availability, those sort of things. A good start is to say, okay, I'm going to run everything within a single data center. If I'm talking about AWS, that would be a single region, different availability zone, those sort of things. So far, so good. Now, what's interesting about that? It's interesting that, okay, everything is in one location. All of these nodes that you see on the screen are near one another. They talk, replicate, blah, blah, blah. So far, so good. Now, the next step is to say, hey, what happens if my data center is down? At which point we are going to say, okay, I need to run on multiple data centers. Now, the key here is that at this point, I have to make a decision what sort of data distribution we're going to have. And we have two of them. We have the multi-cluster and the geo-distributed cluster. The geo-distributed cluster basically means something like that. You're going to take this node and put it in New York, this node in Chicago, this one in London, this one in Tokyo, and this one in Amsterdam. Now, because all of those nodes which compose a single cluster can talk to one another and communicate all of the usual things, if you lose a data center, no big deal. There are a lot of other data centers around. Now, that does raise an issue because now you have to deal with the latency of geo-distributed environment, which basically means that, okay, if I have a node in New York that currently talks to node A, and node A failed, and my web application now needs to go to Tokyo, that's a bad idea. That's a bad idea because the latency between here and here would kill me. In November 2018, GitHub had an outage That outage lasted about 24 hours. And the reason for this outage was that the web application in the West Coast tried to talk to a database in the East Coast, or vice versa. I don't remember which one was which, but the idea was that even within a single country, the latency of moving from my data center to a remote data center was so high that the latency started to get to the point where their services were timing out. That's a big no-no, as you can imagine. Another way of handling that is to say, okay, let's go to multi-cluster. In each data center, I'm going to have a cluster of multiple nodes, and then I'm going to set up replication between them. The idea here is that a node failing in New York would mean that the web application, my application, business application nodes, and all those sort of things would fail to another node in the same data center to ensure locality. We still have replication on all of those, so I can make a write here, and that would show up in all of the other locations as well. Now, regardless of what we're talking about here, the whole idea is that conceptually, all of the nodes, regardless of whatever run in a single cluster, geo-distributed cluster, or multi-cluster, have the same data. It is possible that, I brought something here and it will take a few seconds to minutes to show up here. But if I'm stopping writes to the system and waiting for a bit, all of the data is going to be the same. Same ownership, and this is the centralized model. A different model is the distributed model. In this case, the whole idea is that we have one node, and that node may actually be a cluster. And that cluster or that node pushes the data down. Now, how does it work? The whole idea, a good example here might be in a restaurant chain. And we have the central location, the headquarters, where we set things such as price lists, we set things such as, I don't know, the recipes or whatever. And we update here. And then this is independent cluster, but it replicates to all of those. Each one of them is an independent cluster. Now, the idea in this case is that effectively you have a hierarchy. Here is this is the root of that, and then we flow the state out. This is very the most common distributed system you see for that would be DNS, where an update flows through the system. A key here is that this node is trusted. And this node is trusted because I'm sharing my entire data with you. So either we actually trust this, or this is public information. But regardless, the whole idea is that each of the nodes has access to the same data. Again, we are in a position where all of the data is shared. So far, so good. But what happens if that's not the case? What happens if I actually have a different model where some of the nodes may be evil? Or, maybe I started liking them, but then, it fell into the hands of an evil person. In Israel, we recently had a huge controversy because an ex-wife of a big shot lawyer handed his phone to the press, and that caused a huge uproar. So this is the case of a trusted node becoming untrusted. So another example would be what happens if you actually have some data on a phone. And I have a phone here, and I have an application of that, which needs to show some data. But from the point of view of the central system, my node, my phone isn't trusted. I have the ability to root this phone. I have the ability to listen to everything that goes on. I can run my own code there, inspect the state, all sorts of stuff like that. So the whole idea is that in this case, I have some federation of data that go on across the environment, but I'm not trusting everything. Now, in many cases, that ends up being the real world. Whenever we have systems that are running in an environment that is composed of multiple actors. Two businesses work together. They want to share some data, but not all of that. Or if I want to install something in the edge, and I'm worried that someone may steal that, may modify my hardware there, or just take the hardware and plug it into their own systems and see what I have on the machine. Let's talk about a fun example. We have traffic cameras. The camera is deployed on the road, and there is some unreliable cellular internet, and the whole idea is that we automatically generate speeding tickets. Now, consider the model that we have for something like that. The idea here is that at the camera, we need to be able to take the photograph, analyze them for speed, stuff like that, figure out what is the actual relevant speed for the road segment that we are looking at, and generate the ticket. At the same time, there actually been quite a few cases of people knowing that they got caught with the speed camera, and then they went back and stole the camera or try to damage that. And what happened if someone actually steal the camera? Well, they have effectively they have physical access to the machine, so effectively you have to assume that this is now owned by the thief. So what sort of damage can they do then? If we are using the distributed model where all of the data is shared, where I can see all of the traffic, all of the traffic tickets that were sent across the country or the region, whatever the system is. But I can also probably have the credentials to update data because the speeding camera needs to push data out. So it probably should have some credentials around that. So that's something that we have to consider. How do I handle that? How do I handle the scenario where my camera become evil? This is an issue of trust, as you can imagine. So with RavenDB, we have a whole bunch of features around data replication. If you run a cluster, by default, you're going to have data replication. This is the single cluster model or the geo-distributed cluster model, regardless. Single cluster, you just say what is the replication of the replication number that you want for the database. That's about it. So I can go and create a new database and specify what the replication factor would be. And that's it. That's that. If I say, for example, the replication factor is 3, then the data is going to reside on 3 of these nodes, which is great. But again, that's only work if we have the centralized model. In 4.2, we added the push replication model. And the push replication model is intended for something like this, where you may have many instances that are going across the many instances that deploy across the world, and you need to update them from a central location or maybe a topology of central location, something like that. And again, going back to the headquarters and the machines deployed individual stores. Now I want to talk about how RavenDB supports this scenario, where we have the potentially untrusted data. And in order to handle that, RavenDB allows you to define the following. This is when you define external replication, replicate some data out, and we have the notion of a replication hub. A replication hub allows you to define, okay, replication from hub to the sink. This is the pull replication that you're familiar with from previous versions. But we also have the other way around. We can now specify that Replication Hub can send data to the edge and accept data from the edge. So that is a very powerful feature. It means that you can have nodes come up, sync to the central location, and go away. And that gives you a lot of freedom. But another very important thing that we allow you, we also allow you to do this, to enable filtering. Let's see how that works. I already prepared in advance this thing. This is allow filtering. And now I have this certificate that belongs to Camera 53. But I notice that I'm currently running in Camera's cloud. So this is effectively the central system that we have. And I have this certificate that belongs to Camera 53. And I specified the following setup. I want to send from the hub to the sink. So from the cloud to Camera 53, all of the roads information. And I want to get back from the camera all of the tickets for Camera 53. And that's it. That's the only thing that I'm specifying. On the other side, this is Camera 53. And I have the other side of that. This is how I'm going to authenticate to the Camera's cloud instance. And you can see that I'm going to say, okay, this is what I'm willing to accept. From the hub, from the Camera's cloud, I will accept roads and I will send this thing. Now, what does this mean? Let's go here and define let's say that police ambush plan. Road 2, date, not ambush, blockade it's called. So I'm trying to translate terms from Hebrew to English, doesn't necessarily works. COVID checkup. Great. Now, this happens in the Camera cloud. It does not show up here. Why is that? Because I'm only sending roads downward to the cameras, and I'm only accepting tickets upward from the cameras. So right now I have, this is road 2, and let's say road 6. And now this shows up here. Now, I'm going to go and create another one like this. I will Camera 53, and it might be easier. I'm going to switch between them a lot. Let's find something that I like. Okay, so the white thing here, the light sample, this is the camera. The black is the cloud. And now you can see that, oh yes, this didn't go up. Why didn't it go up? Because it doesn't match the expected. Here we go. This one was sent up as expected. But notice this is actually something really important. This did not match what I wanted to send. So it wasn't replicated the other way around. Now, on the face of it, this seems like a fairly simple distinction. that, okay, I can define prefixes for the documents that I want to send. But this feature actually enabled me to work on an untrusted environment, because now I can say, okay, I'm willing to send you only some data and accept only some data from you. Now, let's talk about some of the other impacts of this. I'm not trusting anything here. If someone owns the camera, then if someone stole the camera and try to look at the data that it has inside, it has only the records that it has. Only the records that were taken by this particular camera. Now, I can't read anything that wasn't taken by this camera. I might be able to modify data that belongs to this. Let's say that right now I stole the camera and I want to change this. Now, obviously, that's not something that I would like to enable. So I'm going to go here and say, hey, you know what? Let's make sure that we have revisions enabled. And something like that. And now we can see that this data was modified, but I can go back and see the old data. Now, this one doesn't have any revisions. This one does. So the whole idea is that because we have independent clusters which don't trust one another, we can control that very nicely. Furthermore, and that's really important, the fact that we are running in this manner also solve a lot of issues from a technical perspective. I have nodes that are running on the edge, they're behind firewall, NAT, all sorts of stuff like that. I may be running in an environment where I'm actually running on mobile system, or I'm just running on my laptop or my phone or something like that, and the IP changes, those sort of things. So I don't really have to think about it. That has all of the usual benefits of pull replication. But now you can do that in a bidirectional manner and without really thinking about that. Now, another thing that is important, we aren't trusting one another. Let's say that in this case, this is very clearly that there is a chain of trust here. The only reason that the camera exists is to report the tickets upward. But the idea here is that that doesn't have to be the case. What happens if we are two businesses that work with one another? So maybe in here, I'm going to say something like this. Hey, I know that you want to give me roads, but I'm only willing to accept this. Now, it's important to understand, in this case, what's going to happen to the data. First of all, we change the configuration. This one don't go away. But then again, if I go here and change the value, oh, yes, so forgot about that. When I'm doing this, I have to do this. Because what happened, I need to renegotiate the connection. So about that, let's try it like this now. Okay. So now I can see this was not updated. Let's try it again just to be sure. No update whatsoever. Now, what's the issue here? Why does it matter? It matters because even though this node is willing to give me this data, I don't want that. I only will need to accept this data. Now you can see it here. So there is a lack of trust between all of those locations. Now we have an answer for, we have a question from Erdan. I'm going to answer that in just a second. Let's talk about what we have here. So we have a central server. Now I'm talking about a central server. It doesn't have to be the case. It is perfectly fine to have multiple of them. You may have a one server that you have that you use for a hub application for one particular reason and another for another reason. For example, you may want to have hub application for the geospatial data and another one for what is the rules of the roads or something like that. Sorry, my mind goes to, this example is fairly limited. Now, the sinks, so remember the hub is this thing and all of those are called the sinks. The sinks is identified with a certificate. So we have a very strong security. The data is encrypted. We have the ability to do mutual authentication, all of those sort of things. The connection is always initiated by the sink, which means that the sink can move and change and all of that. And filter in the bottom, blah, blah, blah. And the dynamic modification of the access level, the only issue here is that you have to reset the connection. Apparently, it doesn't do that automatically. I'm not sure why it doesn't happen. Practically speaking, once you change the connection, the routes that you allow, that's something to consider because it's not going to go back and replicate stuff that you now allow. So for example, if I go now here and allow just roads, save and disable and enable, I'm not going to see the changes to road 2 here. Those already happened. And we aren't going to rerun everything from scratch. That can be an incredible cost. Try to imagine you have a 100 to 200 gigabyte database. You don't want to try, oh, some node started, changed the configuration. We're going to have to restart from scratch. But you can add remove access and that would impact future operations. Now we have a question from Merdan. Can we also filter with a query? I mean by a property on the data. And you can do that. You can do that for a very simple reason. It's something that make it really, really hard to decide how we're going to do that. Let me explain why. Going back to the tickets and roles and stuff like that. Let's say that what I'm going to say is something like, okay, only send the documents that belongs to, I don't know, the northern district to this specific camera, which makes sense. Now, the problem with this is what happened. This is a property of the document. Now, a property of the document is something that can change. But how is that something going to change? Because consider what's going to happen. I have the central document, I have the central server, I have the specific camera. Both of them currently have this particular document in there. So if we use colors and you follow me, this is the current state. Both of them have the document. Now, we change this to be a red color. It doesn't go over the wire, but it doesn't mean that this gets deleted. It just means this doesn't go over the wire. Now, try to imagine, how can this be? This can be because I don't know what the previous version was. I don't know if the previous version was sent or not. And the reason I don't know that is somewhat complicated and technical, because the change may happen anywhere, and there may have been multiple different changes. For example, try to imagine that I have a series of changes that red, blue, red, blue, red, blue, red, blue. What happens here? Do I send it? Do I not? Do I delete it? Do I not? All sorts of stuff like that. Especially because I may have multiple changes that happen on another server and then got to me as a set of revisions or documents or stuff like that. In other words, when we decide what to replicate to the other side, we have to decide on something that is stable. And we use the identifier for that. This is why, if you will notice, when I'm creating the tickets, I'm specifying here tickets for this particular camera. So the whole idea is that this is how I decide whatever to send it or not send it. This also has another very important reason. Let's say that I'm right now here in the camera, CA64, let's say CA62. I'm going to go ahead and create a tickets document. Here we go. Notice that this is 0001A. And now I'm going to create another tickets document. It's the same thing, because the scope of the identifier is at the database level, or at the database group level, if you want to be more specific. Now, if I set it up to allow filtering by property, you would have to have some distinguishing ID in order to avoid conflict if you replicate them to the same location. So we're taking advantage of that and ensure that this is part of the ID. Notice that replication means replication of everything. Mean that we replicate document, attachments, all of those. And again, if I want to replicate time series data, I know that this time series data belongs to a particular document, but having to decide on the content of the document means that I would have to do a lot more complex work. So we're not touching that. We're just saying by the ID because the ID is stable. Hope that this answers your question properly. Now, I gave you the example of cameras and tickets and stuff like that. Let's look at another example. This example is healthcare. In the healthcare example, we have multiple independent parties. So we have, let's say that we have providers, healthcare providers, healthcare clinics, insurance companies, those sort of things. Now, the healthcare provider is talking to the clinic, and probably this should be the insurer, not the provider, but whatever. They need to send some data to the clinic. And this data may be shared, and it's not really secret, typically not sensitive information, even if it's business secret information, billing code, the procedures that you may allow to do, inventory that we have, stuff like that. Some data on a clinic basis is private. I don't want to share to anyone. The employee timesheet, the cleaning schedule, whatever, all sorts of stuff that we don't really care about. We don't care to expose to anyone, any third party. And then there is data that we want to share with the provider. Hey, I got your patient X, and he has blinding headaches, so he needs to take 2 aspirin and call me tomorrow, whatever. Now, try to imagine that you, in this sort of environment, you have a clinic that work with multiple providers and a provider that work with multiple clinics. So the association is many to many with regards to the filter of data. What we actually end up having is this information that we have is not going to end up as the same across the board. And we are sharing some data, but we are going to end up with data silos. Some data is going to be private to one location. Some of my data is shared with some of the other locations, but not all of that. And the whole idea is that we end up with a topology that you control. You don't really have to, all data must be the same, all data must follow those rules. No, you can define your sharing policies as you see fit. The benefit of doing that through RavenDB is that RavenDB takes care of sending the data, updates, revision, conflict resolution, those sort of things, securing the data, encryption over the wire, retries, all of those sort of things, and you can focus on building your application. In some cases, we have seen users who have used RavenDB as a sort of a message bus to all of their environments. Okay, I'm going to write a command to the center server. It's going to percolate to all of the nodes in the edge. Other cases, this is being used to share significant amount of data. Because think about it, the whole idea isn't that, okay, I'm going to have to think about my synchronization processes. No, I'm just going to say, okay, I'm going to follow the rules. I'm going to set up upfront, and then everything is going to follow out of that. And this is a really nice property because it's effectively self-organizing. Now is the time for questions. This is a short webinar specifically because I want to introduce a focus feature. Hopefully we like it, and we're going to do more webinars on specific features, roughly 40 to 50 minutes, and not hour and a half that we typically take. You can start using this today. This is part of the 5.1 release. And previously this was called Pool Replication Hub and Pool Replication Sinks, but we removed the pool, and this is define it, run it, define what you want from here. You can add access. Okay, let's add a different camera here, those sort of things. It should be relatively intuitive and as easy as possible. Notice that you can define user/123 and user/123 or something like this. So this particular user, this is an exact match, and then prefix from here. That's it. I don't think there are any more questions. If you have any, please let me know. Send us an email. We'll be very happy to answer you. Thank you for showing up for this webinar. Oh, 1 second. We have questions. Arash, you managed to hit just before I hit the pause button. Okay, so Arash is asking, I hope I'm pronouncing the name correctly. As a recap, is it safe to say that federation is the right choice to distribute a snapshot of the data? What do you mean a snapshot of the data? A snapshot of the data means the data at a particular point in time. So I want to send the data as it was in Wednesday, 5 a.m., something like that. If you want to do that, there are a couple of things that you can do. First of all, one of the features that we have in replication generally that also applies to replication hubs is the notion that you can say something like this. Okay, I'm only going to replicate the data after some time have passed. And it may be the case that you want to set up this sort of environment where, okay, I have 2 tiers of customers. Some customers are going to use the public feed, so to speak, and they are going to get the data with some delay, and some customers going to get the data as soon as possible. But snapshots of the data typically mean as it was at a particular point in time. I don't know if this is what you mean. If you can expand on that, I would be very grateful. What you can't do, you can't say, okay, I want to replicate up to that particular point. If you want something like that, the backup option is a much better scenario for you. And you can specify, oh, I want to push that somewhere and then replicate from that and this. Now, Rashi is saying, I meant a piece of the data out of the entire data. Yes, if you want to do partial replication, that is just that is just exactly what this feature is for. For example, you may want to say, okay, let's go here. Create sample data. And now what I want to do, I want to replicate all of the data that I have here, but I don't want, I want just companies and orders to be replicated, nothing else. And you can set it up to do it this way. So let's see how we do that. We go to ongoing tasks. And we set a replication hub, orders and companies. And in this case, I'm going to say, hey, I don't know, no district. So I'm going to generate a certificate. I'm going to say, hey, I'm only going to allow employees and orders to be replicated. And I have exported this. And now I'm going to go here, this guy, and set up the other side of this. Now, see that this is all I have. This is something that I created previously. Now, what I've actually done here, I set up one-way replication. Why one way? Because this is just from hub to sink. I can also set up sync to hub and now enable this. But you know what? Sync to hub, I don't want both ways. I want just employees to be changed. So now if I'm going here, and why do we have this? Sorry, that's a UI bug that is really upsetting me. Now, okay, do it that way. And I'm not touching that. From my perspective, I'm willing to send the orders out, but this would be filtered. Just to be sure that we'll accept it as soon as possible. So now, and here we go. I modified orders, I modified employees. We're good. Now, if I'm looking at employees was modified. Orders was not. Now, something really important here. Notice what happened when I modify this. Going to orders. What just happened? It used to be that I had this in uppercase. What's the difference? The difference is that this created a conflict. So let's see what happened. We have this thing. This is the original, and this is what happened afterward. And then we have this thing. Sorry, not this thing, this thing. Somewhere around here, we'll find it. Okay. I have this. This is with the 1.8. That's the change that I made. This is with the capital. We have a conflict because the change that happened here didn't include this determination. So at this point, the conflict resolution applied resolved to the latest version. That's it. That's something that you have to take into account because we are now working in a distributed environment, and you may have to consider updates that happen at a different location, maybe disconnected, and that's part of the reason why the ID is so important. Because you want to know that, okay, a document has one source of truth, one location where it can change. So that's it. I will remind you that if you want, you can go to RavenDB/live demo listing and schedule a meeting with one of our engineers to go over your scenarios. We also have a cloud instances that you can use for free, and we'll be very happy to hear from you. Thank you and goodbye.